Hello everyone, welcome to this video. In this video, we are going to learn how to solve a problem using multiplication rule for probability. Here is the example. Every cereal box has a gift inside, but you cannot tell from the outside what the gift is. The store manager assures you that 14 of the 59 boxes on the shelf have a secret decoder ring. The other 45 boxes on the shelf have a different gift inside. If you randomly select two boxes of cereal from the shelf to purchase, what is the probability that both of them have a secret decoder ring? So here, what they said is uh, 14 out of 59 box have a secret decoder ring. So that is what we know first. So let me write that here. First thing we know is 14 of the 59 boxes have secret decoder ring. And the remaining 45 boxes have different gift inside. So different than this secret decoder ring. So 45, remaining 45 of 59 boxes have different gifts. Now the question is, if you randomly select two boxes of cereal from the shelf to purchase, so when you are randomly pulling two boxes to purchase, that means you are not putting them back. So this is the dependent case. What is the probability that both means first box and also the second box uh, have a secret decoder ring? So now what we are looking for is, we are looking for probability of getting the secret decoder ring in the first and the secret decoder ring in the second. Both means first and second. So I use the word and here. And we know that whenever we are looking for the probability of one quantity and the other quantity, we use the multiplication rule. So this is equal to probability of getting the first secret decoder ring times the probability of getting the second secret decoder ring, which is equal to, now if you look at the probability of getting the secret decoder ring in the first box, we know that we have 14 secret decoder ring out of 59. So it will be 14 out of 59. 14 out of 59. And we are pulling it to purchase. That means we'll not be placing it back. Now the total number changes to 58 in the self. And out of 14 decoder ring, if one is already pulled, the remaining are 13 of them. Because this is the case of the multiplication rule and this is the dependent case. Or dependent events. So because we have the dependent events, the total number of the boxes in the self has changed from 59 to 58. We are looking for the secret decoder ring in the first, which we have 14 in all. Now, once one is pulled, we'll have 13 remaining. So now, in order to simplify this one, we multiply numerator with numerator. So when you multiply numerator with numerator, it will be 14 times 13, which is 182 over denominator times denominator. 59 times 58 is 3,422. So that is the probability, or approximately if we change it to decimal, it will be 0.532, 0.0532. 0.0532. So this is how we can use the multiplication rule for probability to solve the problem like this one. So whenever we see the word and, we have to use the multiplication rule. And then while using the multiplication rule, we have to be very careful whether the events are independent or dependent. Here the events are dependent because you are pulling these two boxes and you want to purchase that. That means when you pull the first one, the number of boxes in the shelf will be reduced. That means the probability of getting the second one is affected by the first one. That's why this is the case of the dependent events. Thank you so much for watching. I hope you find this video helpful.